Hello, thank you for tuning in to watch my talk on techniques for flexible responsive visualization design. My name is Jane Hoffswell and I'm currently a PhD candidate at the University of Washington. This work was done in collaboration with Wilmot Lee and Zhicheng Liu from Adobe Research here in Seattle. I'm also really excited to share that this work received a CHI 2020 Best Paper Award, so please go take a look at the paper after this talk. And just so you know what we look like, this is us. I'm going to start this talk with a question for you. Think about the last news article you read. What device did you use? Did you say your phone? Because in general, mobile devices are now more common than desktop or laptop computers for reading news articles. While the text content of a news article can easily adapt via reflow, it is non-trivial to create responsive visualizations. Simply scaling the design is rarely good enough for complex visualization designs, as the content may become too small to read or interact with. Instead, design should change to appropriately adapt the new form factor. To really understand how people create responsive visualizations, we surveyed the responsive visualization techniques used in 231 news articles from 12 sources. We then interviewed 5 journalists selected from this corpus about their responsive visualization design practices. Based on the survey and interviews, we identified 4 design guidelines and developed a new system for responsive visualization design. To demonstrate the utility of this approach, we recreated 7 responsive designs using our system to emphasize a flexible design workflow. For the survey, we collected examples from best of lists for visualization designs and galleries for individual sources. Overall, we looked at 231 visualizations found in news articles from 12 sources, including the New York Times, Reuters Graphics, and 538. For each visualization, we labeled the visualization type to ensure that the corpus covers a wide spread of different designs. We then used an open coding process to identify the changes between the desktop and mobile visualization in both the portrait and landscape orientations for the phone. Take a look at this visualization from the New York Times article, "The Places in the US Where Disaster Strikes Again and Again." How many differences can you see? Maybe pause the recording for a minute and take a look. This article is also available at the link shown here. To answer my own question, I would say there are 10 types of changes. The visualization has been resized for the smaller width of the phone. The title and subtitle have been repositioned to the top of the visualization. The text showing the disaster cost for the labeled bars has been removed. The labels have been shortened to remove the redundant word hurricane. The labels have also been repositioned into the chart area rather than the white space. A small tick mark has been added to connect the label to the corresponding bar. There are fewer grid lines or tick marks on the y-axis. And the remaining grid lines for the y-axis have been extended to fill the whole width on the phone, which includes repositioning the axis labels. Finally, the labels for the x-axis have been abbreviated. As you can see, there are a lot of changes for this visualization, but making such careful updates to the design can be difficult and time-consuming. Based on these open coding labels, we labeled each technique based on the type of editing action used and the visualization element to which it applies. We then counted the number of techniques that we saw across visualizations in our corpus. This grid shows the types of techniques used when adapting a desktop design to a mobile design in the portrait orientation. We also repeated this process to check for the changes in the visualization in the landscape orientation. Based on the results of this survey, there are 3 key takeaways. In general, we observed that more responsive techniques were used for the portrait orientation than the landscape orientation of a phone. Notice the more full grid on the left. In other words, visualizations in a landscape orientation were less likely to exhibit changes from the desktop design. We also noticed that it was much more common to remove visualization elements from the desktop version than to add new elements on the mobile version. Finally, we noticed that most visualizations exhibited rather small shifts in the content or layout, but a small subset of designs exhibited drastically different layouts on different devices. The visualizations shown here are a few examples of the types of drastic changes we saw in our survey. As the next step, we interviewed 5 journalists with prior experience designing responsive visualizations for news articles. In particular, there are 3 takeaways that I want to talk about now. One interesting takeaway is that designers often exhibit a desktop-first development approach. As one participant stated, by virtue of sort of sketching graphics on my laptop or on my desktop screen, often the first iteration of something works best at those screen widths. Since the default working environment is a desktop, the designs often reflect that default rather than the more common expectation that visualizations will be viewed on mobile. Another participant noted that much of the programs we use are geared toward desktop first, or feel that way anyway. So if all of them had a slight shift in default or in tone, I feel like that would also help us to think that way. When it comes to actually creating the responsive design, participants did note some important benefits of thinking about the mobile design early in the development process. In particular, one participant explained that there's a hierarchy of information, right? So as you go down in the artboard size, you make the decision about what information can be cut first. Participants also noted that creating mobile designs encourages designers to focus on what's essential, and it makes us more concise and it makes us get to the point quicker. Finally, there was a user requirement for fine-grained control of the designs, which tended to encourage participants to prefer developing separate designs over using dynamic resizing. One participant explained that dynamically positioning things like labels and annotations at every possible screen width is very easy for that to go wrong, and having a fixed number of breakpoints tends to be a little bit less error-prone. However, challenges may also arise from using these separate designs. Another participant explained that it's annoying when you have to make changes to 3 or 4 or 5 different artboards, and that usually introduces mistakes. So that's one of the reasons why the design for mobile comes later. In order to avoid errors from having too many different designs, journalists would often only implement the responsive design once the idea for the visualization was fully formed. Based on the survey and interviews, we identified 4 key design guidelines for a new visualization authoring system focused on responsive visualization design. The system must be able to show cross-device previews of changes and design decisions, enable simultaneous cross-device edits, facilitate device-specific customizations to the design, and support propagation of edits between designs for different devices. I will talk through these techniques more with a demo of our system based on the New York Times visualization showing the cost of natural disasters. The main part of the system is the canvas, which shows a separate view for each visualization of interest. In this case, the designer is working on a desktop, a portrait, and a landscape visualization. On the left are the system panels, which show details of the visualization design similar to systems like Adobe's Data Illustrator. The first panel is the Views panel, which defines the name and size for the different visualization versions. The second panel lists the datasets and fields that can be used to construct the visualization. Similar to other design systems, the third panel displays groups of visual elements, such as the text marks, that act as layers in the visualization design. Finally, the last panel contains information about the visual encoding decisions for the selected mark. This panel updates based on which visual element is selected, and users can also view the variation across designs. For example, the user can see that some designs use a left alignment for the text, whereas others have been customized to use a right alignment. As the user constructs the visualization, all 3 of these visualizations are updated simultaneously. In this video, the user wants to produce a second text mark to show the cost of the natural disaster in addition to the name. By supporting simultaneous editing, The user can maintain consistency across designs and therefore freely experiment with changes to the design. However, notice that the current design is somewhat ineffective for the portrait visualization. In particular, there is a large amount of white space that seems excessive for this use case and severely narrows the width of the bars. The designer may therefore want to customize this view to remove that white space. To customize the visualization, the user can start by selecting only that design, thereby locking the other views to prevent changes. Notice that once the visualization is selected, the other views are partially grayed out and frozen in the system. Now, the user can modify the design by removing the recently added label to display the disaster cost, thus reducing the amount of text shown on the smaller view. The user can then update the labels to remove the redundant word hurricane, thereby shortening the text to make better use of the space. Next, the user updates the alignment of the labels and can reposition the text into the chart area to remove the white space via drag. Notice that the visualization bars automatically update to fill the vacated space. Finally, the user duplicates the text mark and changes it to a tick mark which connects the labels to the bars of interest. Throughout this process, the user changes have only applied to the portrait visualization. You can see in the background that the desktop and landscape visualizations have not changed at all during this process and remain frozen at the prior state. The final goal of this system is to support propagation of edits. In other words, to allow users to reapply changes from one design to another. Let's skip ahead in this demo to see how that would look. Notice that in the portrait and landscape visualizations, the title has been customized to a different position. To propagate edits from one view to another, we can view the variation to the design in the Attributes panel, preview the impact of changes, and remove design decisions to synchronize the two visualizations. We can repeat this functionality for both the title and subtitle to fully synchronize these two designs. To demonstrate the utility of these techniques, we recreate 7 responsive designs using our system. These examples were selected to show a range of visualization designs, responsive techniques, and interactive capabilities. To see the full video demos for several of these examples, please take a look at our supplemental material, which can be found here. The main takeaway of these reproductions is that responsive designs can now be developed using a flexible workflow in contrast to the linear development process described by journalists. In conclusion, we contribute a survey of responsive visualization techniques which shows that designs employ minor modifications and generally remove content from mobile visualizations. We also contribute interviews with 5 journalists about their design process that highlights a linear desktop-first development process driven by system defaults. Based on these results, we contribute a system for responsive visualization design that emphasizes simultaneous editing and customization by foregrounding design variation. And finally, we contribute reproductions of 7 responsive visualization designs that demonstrates a flexible design workflow in contrast to the linear development approach described by journalists. Thank you for listening. Please take a look at our paper if you would like to learn more, or check out the full video demos in our supplemental material, which is available at the link shown here.